All right. Hey, this is lesson 8, just the first part. Okay, so we're going to go through mostly a review. This is stuff you should have learned in Algebra 1, but again, we know how that goes. Yeah. Okay, so we're going to talk about monomials. Mono means 1. Okay, mono means 1. So this means something that only has one term. So like the number 5, okay, 8x, negative 3x squared. Like all of those are monomials. They're just one term. Because things that are more than one term are going to be separated by a plus or a minus sign, right? Okay, so we have to use exponent rules to simplify these. Okay, so rule number 1, or just a refresher on rule number 1, it's called the product rule. It says when you have something to the m power and you multiply that by that same something, this is the same base raised to another exponent. It could be the same exponent, it could be different. Okay, when we multiply these two things together right here, we're going to technically add these exponents. Okay, so for example, if I had x to the 3rd power times x to the 4th power, okay, this is x times x times x, right? 3 x's. And this is x times x times x times x, 4 x's. So if I multiply those together, I'm just going to add these two exponents, and we're going to get x to the 7th power, right? Plus goes in the middle there. Okay, add the exponents. Even if it's a negative, you still add it, just like you would normally add positives and negatives. You do the things, okay? All right, the power rule says if you have a base number raised to an exponent, and you're going to take that whole thing in parentheses and raise it to another exponent, in between here, like right here, is going to be an imaginary multiplication sign. So we're going to take a, and we're going to raise it to the m times, oops, that's an n, make that an n, sorry. That looks horrible. M times n. That's better. Okay. For example, if we took x to the 2nd power and then we took that whole thing and raised it to the 7th power, that means we're taking x squared times x squared times another x squared times another x squared times another x squared, and we're going to multiply that so many times it's going to be x to the 2 times 7 power, which gives us x to the 14. Okay. Quotient rule. Quotient means divide, where product means multiply. Quotient is divide. So if we have something to the m power and we're going to divide it by that same something to the n power, instead of adding the exponents, we're going to subtract them. And remember, in subtraction, order matters. So we take whatever number is in the numerator on top, we start with that one, and we're going to subtract whatever's down on the bottom. For example, if I have x to the 7th divided by x to the 2nd, okay, this means right here I have 7 x's on the top, and this means I have 2 x's on the bottom. Okay, so some of these two are going to cancel with some of these up here, and they're going to leave us with whatever 7 minus 2 is, which is 5. Okay, same thing here. If you have negatives, just take whatever number is on top, subtract whatever number's on bottom, use your rules with positives and negatives, and it'll be okay. Okay. All right, negative exponent rule. Somebody along the line decided that we're never going to have negative exponents in our answers. So if you come to a final answer and you have something to the negative power, all you're going to do is you're going to do the reciprocal of it. You're going to put it under 1, and then you're going to drop off the negative. Okay. So for example, if we have x to the negative 2 power, I don't want to leave the negative 2 power, so I'm going to drop that down to the denominator and make it positive, and then we just put a 1 there to hold the spot. Okay. Also with this, if you have a negative down in the denominator, you're going to bring it up to the numerator. So if my final answer has something like a to the third, b to the negative 2, we'll just put a 4 up here to hold its spot, okay? Okay, all of this is fine except for this b to the negative 2 power. I can't have that. So what we're going to do is we're going to take this and we're going to flip it up to the top and we're going to change it to positive. So the 4 stays there. The a to the third stays there because those aren't negative or anything, but I'm going to get rid of this negative exponent by moving the whole thing up to the top and making it positive. Okay? Only negative exponents can't be left in our final answer. Okay, and then the last rule is the 0 exponent rule. If you have anything to the 0 power, it is always going to equal 1. Okay, so if you have a whole bunch of stuff, like I can put whatever I want to in here. If I have a 0 out here, my answer is going to be 1. Okay, so this could be like 7x squared. Like, it doesn't matter what's in there. It could be a fraction, it could be anything. As long as that whole thing is raised to the 0 power, it's going to be 1. Okay, unless it's 0 to the 0 power. You can't start with nothing and then raise it to the 0 power and all of a sudden have something. So that's going to be undefined if you have 0 to the 0 power. All right, so look at some examples for this. All right, just a note, if we're going to add or subtract monomials, we need to make sure we're combining like terms. So they have to have the same variable and they have to have the same exponents, and then we can combine the coefficients or the numbers in front. Okay. All right, so I'm going to grab a highlighter to make this a little bit easier to visualize just as we refresh our memory. Okay, so first things first, okay, I don't have any parentheses at raised to a power. Like here, I have a parenthesis raised to a power, so I'm going to have to do something a little bit different with that first. Parentheses go first, okay? Then we're going to multiply or divide. Well, this is a multiplication sign right here in the middle. So we're going to just sort of rearrange this. We're going to take this 5 and this negative 7, and we're going to multiply those together. 5 times negative 7 makes negative 35. Okay. Then we're going to take the other stuff, whatever is the same variable, we can combine together. So this has an x to the 2nd power, and this has an x to the 6th power. So if we have x to the 2nd power times x to the 6th power, that's this product rule right here that says if we have the same base, which are our x's, raised to powers, we're actually going to add those exponents together. So we're going to do 2 plus 6, which makes 8. So this is my final answer, negative 35x to the 8th power. Okay. All right. On number 2, I still see multiply. I'm going to multiply these two things together, but first we got to take care of this exponent here. So this has an exponent of a 2, and what we're going to do is we're going to essentially distribute that 2 to the entire problem. Okay, so we're going to take this exponent and we're going to put it with this negative 2, which is going to look like this, negative 2 to the 2nd power. And then we're going to take that 2 and we're going to push it with the a. So that's a to the 3rd power raised to the 2nd power. And then we're going to push it to the b, and that's b all by itself, and we're going to raise that to the 2nd power. Okay, then I'm just going to bring down, well, let's not worry about that other stuff right now. We'll bring that down in a minute. Let's get an answer for this stuff first. Okay, negative 2 to the 2nd power is negative 2 times negative 2, which is positive 4. A to the 3rd power raised to the 2nd power is this power rule right here, which means when we have an exponent raised to another exponent, we're going to multiply those numbers together. So what I do, this is just me, I put a little multiplication sign in between those, okay, so that I can know that I'm just going to do 3 times 2, which makes 6. Okay, this b is being raised to the 2nd power. What number is really here on this b, when it doesn't have an exponent, it automatically has a 1, right? So then we're going to do 1 times 2, which is still just the 2. Okay, so if it doesn't have an exponent, you're going to bring the exponent over onto it, which is essentially that number times 1. Okay. All right, so now I can bring down this whole thing. We're going to bring it all the way down to right here, 8ab to the 9th. And now I'm going to multiply these two things together, just like we did on the last problem. So we have these numbers that are out in front. They're called coefficients. We're just going to multiply those together. So we're going to take 4 times 8, and that will give us 32. I'm going to put my answer over here. So that gives us 32. Then what else do we have? We have some a's. Here's an a to the 6th, and a to the, what number's on that a that we don't see? There's a 1 right there. So what am I going to do with my exponents now? If I take a to the 6th times a to the 1st, what are we going to do with those exponents? We're going to add them. 6 plus 1 makes 7. Okay, now we got the a's together, and then the last thing would be to get the b's together. So here's a b to the 2nd power times b to the 9th power. B to the 2nd power times b to the 9th power. And when they're right beside each other like that, we're going to add the exponents. So 12 plus 9 makes 11. Okay, and the rule is, in your final answer, you can only have one of each letter. So you can't have more than one A, you can't have more than one B. And you only want one number in front. Okay, if it's a fraction, you can have a number in the numerator and a number in the denominator. Okay, but we don't want extra terms that we could actually go ahead and combine. So we're going to combine everything that we could throughout our answer. Okay. All right, number 3. All right, let's see. We have 54 m to the 6th and 4 over all of that. Take away 10. Okay, so no parentheses. I don't have to worry about that. Then we have multiply or divide. This line right here is a division bar. So we need to divide and take care of all of this stuff first, and then we'll subtract that from it. Okay? So I can just split this out into separate problems. I'm going to take the coefficients, the numbers in front, and that just says 54 divided by 3. So I'm going to grab my calculator real quick. 54 divided by 3 is 18. Okay. Then I have these m terms right here. So that's going to be m to the 6th over m to the 2nd. And those are right over the top of each other. So what do we do with these exponents? It looks like this, quotient rule. So we're going to subtract. So 6 minus 2 gives us 4. M to the 4th. And then we do the same thing with the n's. I got an n on the top and an n on the bottom. If I didn't have one in both places, then I would just write it into my final answer. Like I don't have to do anything with it. But since I have one in the top and one in the bottom, what exponent's on this one down here at the bottom, since it doesn't have one? That's a 1. And now what are we going to do with these exponents? We're going to subtract them. So start with whatever's on top. 4, take away 1. That makes n to the 3rd. Okay, so now we're going to, all of that goes together. 18, m to the 4th, n to the 3rd, and now we're going to bring all this stuff down. Minus 10, m to the 4th, n to the 3rd. Hey, do you see how those have all the same variables and the same exponents? So if all of that's the same, I can just do whatever these numbers say. This is 18, take away 10. 18 take away 10 is 8. So my final answer is 8, and then all of that stuff, m to the 4th, n to the 3rd. Okay, all right. Can you try number 4? Pause. See if you can get an answer for number 4. Okay, so hopefully you notice that there are no parentheses, so we're just going to do the numbers. So that says 2 times 10. 2 times 10 is 20. And then we have this k to the 4th and a k to the negative 7. K 4th times k to the negative 7. So those are being multiplied together. So what should we do with those exponents? Add them. 4 plus negative 7 makes negative 3. But I can't leave a negative in my answer, so we're going to take this negative 3, which is currently in the numerator, and we're going to make our answer into a fraction. So the 20 stays on top because that was in the numerator, or the top to start with, and we're going to take this k minus 3 and we're going to push it down here to the denominator and make it positive. Okay, so we're just going to sort of like flip it from top to bottom for that purpose. Okay. All right, I think we're going to do 1 or 2 more, and then we'll get to the back. All right, number 5. Okay, I see all of this stuff right here has a power of 2. So I have to deal with that 2 before I do anything else. This one over here doesn't have an exponent, so that's just going to sort of hang out there. So I'll stay together. All right, so we're going to take 2 to the 3rd, and we're going to raise it to the 2nd power. We're going to take r squared and raise that to the 2nd power, and s to the 7th and raise that to the 2nd power. So what is all that going to give us? Okay, 2 to the 2nd power is 4. 3 to the 2nd power is 9. R to the 2nd power to another power, this becomes multiply. That makes r to the 4th. S to the 7th raised to the 2nd power, that's again multiply, so that makes s 14. Okay, then we're going to bring all this down. 1 over 6 r3s. So now we just do each little part. This is multiply. 4 over 9 times 1 over 6. Just multiply straight across. 4 times 1 is 4. 9 times 6 is 54. 54 divide 4 over 54 becomes 2 over 27. Doesn't go any further than that. So my final answer is going to have a 2 over 27. And then we need to deal with the r's. So this one has r to the 4th and r to the 3rd. What are we going to do to those exponents? We're going to add them together. So 4 plus 3 makes 7. That's positive, so it's going to go up here in the top, r to the 7th. And then we do the same thing with our s's. This says s to the 14th and s to the, there's no number on that, so what's there if there's no number? 1. So 14 plus 1 makes 15. And again, it goes on the top because it's not negative. So 2r7 s15 all on the top over 27. Okay. All right, so on number 6, see how it has this -1 exponent? I don't want a negative exponent, so what I can do is I can just flip this whole fraction before I start and change exponent to positive. I just flip the whole thing upside down and get rid of the negatives. So this is the same as 7w to the 3 over 14w to the 12 raised to the positive 1 power. Okay, and anything to the positive 1 power is just that number itself, so you don't really have to worry about that part. Okay, so that's just going to be the same, 7w3 over 14W12. And now I'm going to check my numbers. I got these big numbers in the front, the coefficients. That says 7 over 14. 7 over 14 is the same as 1 over 2. And then I have these W's, one on top, one on bottom. So what are we going to do to those exponents? When you have one on top and one on bottom, you subtract them, start with the top. So we're going to do 3 minus 12, which gives us negative 9. So that negative 9 would go here on the top. If you subtract the two numbers, whatever you get, it goes on the top. But I don't want to leave that as a negative exponent, so we're going to change it to a positive, and we're going to drop it down here to the bottom. So we're going to have 1 on the top all by itself, the 2 down on the bottom, and then bring down the W to the 9th power. Okay, last thing before we move on to the back, which is the really easy part. This is sort of the challenge for today. Okay, the last thing that I want to look at here is this negative 3c to the 4th power. Okay, whenever you have a negative or a negative number, like it could just be a negative by itself, which would be a negative 1, okay, or a negative number, you have to make sure that you take that negative number in parentheses to the 4th power. Okay, don't just type it in as negative 3 to the 4th. Your calculator will give you a wrong answer. So your calculator will do 3 to the 4th power and then make it negative. So don't do that. This is negative 3 times negative 3 times negative 3, which is going to be parenthesis negative 3 raised to the 4th power, which is positive 81. Okay, and then we have c to the 4th power, which we won't do anything with. Okay, well, let's just go ahead and finish this. C over c squared, and we're going to raise all that to the 4th power. So again, this exponent gets distributed to everything. So we'll have c to the 4th power on the top, and if I already have c to the 2nd power, and we're raising that to another 4th power, that's going to look like this, c squared raised to the 4th power. And what are we going to do with those two exponents? We're going to multiply them together, which makes c to the 8th. Okay, so I'm going to take this and combine them together. I'm going to push it over here. C to the 4th over c to the 8th times 81 c to the 4th. And if you want to put this over 1, so that it has a numerator and denominator, so that you know that those numbers up on top go together, that's fine. Okay, so if we go straight across the top, we're going to have, this is a 1 right here in the front, times 81, so that's going to be 81, and then I have 4 c's here and 4 more here. So what do we do with the exponents when we go from side to side like this? We're going to add them together, c to the 8th, and down here on the bottom, 1 times c to the 8th. Hey, guess what? C to the 8th and c to the 8th are the same thing. Excuse me. So they're going to cancel out. Or you could do 8 minus 8 is 0, right? Anything to the 0 power is 1, and that just goes away. So we're just left with the 81 all by itself. Okay. This is the challenge for today, is being able to get those exponent things together. Okay. All right. Easy part over here on the back. Just get through the rest of this. Okay, a polynomial, poly is multi, okay, many monomials, okay, poly means more than one term. So you're going to have a plus or a minus between each of your terms. Plus or minus between your terms. Okay, polynomial is the sum or difference. Sum is plus, difference is minus, of many monomials. The highest exponent of our polynomial is called its degree. So that's how we label it. Like, so you know, like on quadratics, we always have to have the biggest exponent as an x squared. Okay, so if we had an x to the 3rd as the biggest, or an x to the 5th, or an x to the 27th, whatever, we're just going to look through the whole polynomial, the whole problem, and find the biggest exponent. Okay, when we're asked to put it in standard form, we always write our exponents in descending order. Write the exponents in descending order. That means from big to little. Descending. Okay. So it's really easy if you only have one variable. So like on number 10, our variable, the only variable in the whole problem is k. The biggest exponent on the k, that has a 2, that has a 3, that doesn't have one, so that's a 1. That doesn't have a k. So this is our biggest exponent, right? So we're going to start with that one, negative k to the 5th, and then we're going to work our way down. So after 5 would be 4. Is there a term that has a 4? Nope. Go to the 3. This one's the 3, minus 3k to the 3rd. After 3 is 2, so that's going to be this one, plus 1/4 k squared. And then after 2 is 1, and then the constant is always at the end. Okay? It's a little different if you have more than one variable. So typically when we have more than one variable, we're going to start with whatever letter comes first. So on 11, we would start with A. Okay? So we're going to start with the biggest A exponent, and we're going to work our way down through all the A's, and then we're going to sort of work our way back through the B's, okay? And usually it'll go down through the A's and then back up through the B's. Doesn't always really work out that way, okay? So when I look at my A values, this has an A to the 3rd. That doesn't have an A. That has an A with no number, so that's a 1. This is A2. So this is our biggest A term. So we'll start with a positive 4A to the 3rd, and then work our way down. So then A squared, 18A squared B squared would be next. After A squared is A, so that's the 7AB. And then we only have one last term that doesn't have an A, and we just sort of tag it on the end. Okay? All right, so that's the idea of standard form. And then our last thing here is classifying polynomials. Okay, polynomials are classified by their degree or their highest exponent. So this term that was in the very front is going to be the degree of our polynomial. And then we're going to count the number of terms, and we're going to give each polynomial a name. Okay, so if we don't have a degree, so if it's just a constant all by itself, okay, it's just a number. It doesn't have a variable with any exponents. That's a 0 degree, and that is called a constant. If it has something to the first power, we call that linear, mx plus b, right? All of our straight lines have x to the first power. Anything that has x to the second power is quadratic. X to the third power is cubic. X to the fourth power is quartic. And to the fifth power is quintic. Okay, and it always goes on our variable. So this is going to be x to the 0 power, x to the first power, x to the second, x to the third, x to the fourth, x to the fifth, right? The biggest term. Okay, so let's do a few of these. Let's pick these 3. Okay, so on number 14, if we were just going to give it a name by the degree, what is the biggest exponent in number 14? That looks like a 5. So x to the 5th power is going to be called quintic. Yeah? Okay, number 15. What's our biggest x value? There is no x value. Okay, no x, so that is called constant. It's just a number all by itself, no variable. Okay, and number 16, biggest exponent on the x is this one right here, x to the 3rd power, and so that is going to be cubic. Okay with that? All right, and then the last bit is we can also give it a name according to the number of terms that it has. So if it has one term all by itself, remember separated by plus or minus, we call this monomial. If it has two terms, the prefix for two is bi, like bicycle. So this is a binomial. Three terms, the prefix for three is trinomial. Anything after that, we don't have a special name for it that we use. We just call it the generic name polynomial. Okay, so it just has a bunch of terms. Okay, if it's less than that, we usually give it one of the special names. Okay, so let's go back and give these our second term for each of them. So on number 14, how many terms does this have? This has 1, 2, 3, separated by the plus or minuses, so that's 3 terms, which makes that a trinomial. 3 terms, trinomial. Okay. Number 15 has how many terms? 1 term, so that's going to be a monomial. 16 has 1, 2, 3, 4 terms, polynomial. Okay. All right, so what I would like for you to do right now, please, is to take the assignment or get the assignment, which says number 8 up in the corner, and I would like you to do numbers 1 through 6 and 9 through 12. For right now, don't cross the other ones off, okay? I'm going to ask you to do some of the other problems here in just a little bit, okay? So to start with right now, problems 1 through 6 and 9 through 12. So simplify using your exponent rules here for these first 6. And then 9 through 12 is write in standard form if needed, like make sure they're in order from biggest exponent to smallest exponent, then classify. And when you classify, you should have 2 names for your classification, one by the degree and one by the number of terms. Okay, classify polynomial, 2 names. All right, ready, set, go. Love you, bye.